All right, if someone can just say yes, that they can hear me, then I can start out here.
Yes.
Oh, good. Yeah, that was in voice. I'm not used to that. Okay, perfect. We're kind of taking a turn now in the course to a different sort of topic. And that topic is basically semi-structured data, is what we're going to now. Let's see here. Just want to get this set up right here. Oi. Very good. All right, so yeah, so we just covered normalization theory, and if you recall, we had this assumption of 1NF, first normal form. And this first normal form basically just means that everything's tabular, right? So we have a table looks like this, and then each of the tuples or rows, the values here are atomic. So we would allow for something like the value of A, but first NF, it could be a string, it could be a number, 12, it could be a date, 2009, 11, 01. But they're all atomic. These are all atomic values. Let's see. Is that? Yeah. I guess you guys can see that. But what we would not allow here is we would not allow something like a list. So Mike, Dave, okay, and John. We would not allow a list in here. That would break first normal form. But that's a little bit restrictive. So there is, there's nothing that says you can't. I mean, we would just, if we want to stay in first normal form, we would not allow this. But there's nothing that says we won't allow this. I mean, we in fact would let it through. In PostgreSQL, you can actually have like lists as data values. So the theory, surprisingly, actually, the theory stands up okay under this. So a lot of these functional dependencies, you can still have functional dependencies in things like this, and you can still reason over them. So it's actually kind of, some of it gets, I mean, so you lose parts of it, but some of it actually stays around a bit. So you can talk about putting things into kind of normal forms. But typically we kind of, at this point, we kind of abandon this. And what we when we go to this in a full way here, we allow for, we can allow for, I mean, in the relational sense, what we can allow for here is we can ultimately allow for arbitrary tables to be cell values. So what you get in the classic non-first normal form databases, what you have is you have something like, you have tuples, and the tuples might have something like a name, and then it might have something in here like, let's say, expenses. Okay, and then in this right here, in the value for expenses. So normally under first normal form, this would, what do you mean expenses, right? But actually inside of here, we could have a full table. We could have something like ID of the expense, and we could have the description, amount, and then we could have a full database in here. Just for the actual value of, let's say, Dave's expenses. There could be a full database inside of here. So that this right here is, there's actually a formal definition of this, and it's called the nested relational algebra. So when we talk about the nested relational algebra, that is a classic way in which you can actually do this. You can actually have these nesting operations and these unnesting operations. And by doing the nesting, it's just, you actually only add one operation to the relational algebra, the operation of nesting, well, two, nesting and unnesting. And it's kind of an elegant way that in which you kind of preserve the whole kind of relational way of doing things, but you allow for a much more expressive data model. All right. Now, a lot of the stuff when the nested relational model, a lot of things like BCNF and all that, they're around weakly. I mean, you can still talk about normal forms, but they're not as satisfying as them when you're doing it under first normal form. right? So that's kind of theoretically kind of where things are going. That's kind of a direction mathematically in which you can take things with the nesting and unnesting operations in relational algebra to get to break a first normal form. Okay, so this is just to kind of relate it back to the theory we were talking about earlier. All right, but the thing is that this stuff is actually, there's another way of looking at this kind of stuff, and it's just, which isn't so theoretical, and that's kind of what we're going to pursue here, because we're going to be more practical in our orientation. Now I imagine, you know, and just actually maybe I can finally do like a show of hands here on the participant, because I haven't really been doing so much with the Zoom participant stuff. But a show of hands, how many people have used XML? So we have XML. Just want to see how many people have used. Okay, got a lot of hands showing people who've used XML. All right. How many people have used JSON? Actually, I should probably stop and say, okay, I'm still probably getting XML answers. Okay, so stop saying it for XML, now answer for JSON. All right, I got some people saying no, got some people saying yes. All right, these are very closely related. In the future, actually, in this course, I'm going to probably phase out XML. It's kind of in there for historical reasons, and actually, it's a legacy system, so you actually do still come across a lot of XML out there. But things tend to be now transitioning into JSON. Okay, but they're kind of equivalent in a way, or they're very, very closely related. So what you learn about XML, we can maybe talk briefly about the JSON alternatives. JSON's kind of there's a well, I'll just kind of say it right up front. There is a growing kind of growing set of standards and a growing set of kind of capabilities here. There's something called GraphQL. Has anybody heard of GraphQL before? Raise your hand if you have. Okay, I'm not seeing anybody who's heard of GraphQL. GraphQL actually it's pretty interesting stuff. I mean, this ultimately is kind of going in a direction. I mean, so how many people have programmed in JavaScript? Anybody? Oh, we got some people saying JavaScript here. Yeah, so JavaScript is basically, I mean, one of the trends that's happening now, it's kind of one of those kind of general computer science trends, you might say, is that more and more stuff is actually is winding up inside the browser, is running inside the browser. So it's kind of getting closer and closer to the client. So a lot of your code is going to be running inside the browser now. So, I mean, the stack that you're going to have, I mean, there's kind of traditional stacks which go all the way down to a relational database, but we have this kind of GraphQL stack where you basically have, you know, you have something running inside the browser running JavaScript. And then they can send out these queries. So instead of doing basically, you know, this is like an endpoint here. Instead of doing the normal like REST calls into an endpoint, what you can actually do is you can actually put in queries in this GraphQL, and then the endpoint itself can actually solve a lot of stuff. You can just do it in one trip. You basically specify a complex query, and you know, with complex data, and you basically send it in as a GraphQL query, which looks a lot like JSON, and that gets filled in, and then you get a bunch of data passed back to you, and you do it in kind of one move, and then you're doing most of your client programming is being done inside of, or most of your client programming is being done inside of JavaScript. So it's really nice, because what it does, it just basically says, maybe when we get to the architectures for database architectures, this is really kind of simplifying the middleware and kind of reducing the middleware to something really, really basic, so that most of the work is being done then in the client. And that's kind of nicer, because you get better performance that way for the user. There's a lot of benefits to that. Okay. Anyways, but this is all kind of just kind of a background and kind of motivation for, you know, kind of showing that this stuff is relevant and kind of going places. But what we're going to do now is we're actually going to look at XML, which again has a lot of these properties. So the XML is what we're going to cover in this course. But probably in the future, I'll probably get rid of XML and I'll go to JSON, most likely. But that's for the future. All right. So now let me just share my screen to give this. To get back to the lecture here. Okay. All right, so I trust people can now see that. People see my screen? Yes? All right, I'm assuming people say, oh, okay. Can people see this XML document type definitions screen? Can somebody just say yes, please? So I can.
Yes, we can see it.
Good. Again, a real voice. All right. Okay, so let's talk about XML then for this bit, and hopefully, I mean, for a lot of people, you've seen a lot of this before, but let's just go over it again here. All right. So XML. There's two basic types of XML. There's the well-formed. There's two different use cases basically. There's well-formed XML, which just basically says you have to use tags and attributes in a nesting way, so that you don't violate the basic rules of the syntax of XML. And then there's the valid XML, which conforms to a certain document type definition. All right, and boy. So well-formed XML just basically says that you're going to start out your document with this basically you're going to send it, you're going to kind of declare it as being an XML document, and you're going to say, well, you're going to say standalone equals yes. So this is an attribute here, right? This is a standalone equals yes, and that means that you don't have any document type definition provided. So I always kind of crack this one joke where I say, how many people have heard of what was it again? I can't remember actually what it's called again. XML. Well, I think it was MP XML. So MP XML, I think that was the name of the standard. That was a standard that was developed a long time ago for data exchange in the meat and poultry industry. All right. So basically, we talk about when you're doing kind of like options trading on chickens and pigs and stuff. So those documents didn't just allow people to kind of declare anything. That it had to conform to a certain, almost like a schema, so that it always had, there were certain attributes that would be kind of included or not. And a lot of these things kind of defined industry. They defined industry standards for data exchange. Okay, so that was kind of one of the initial uses of this XML stuff. But basically, well-formed XML doesn't even have that. It's just kind of, you just kind of write it down, and you basically just have it so that you have to balance the documents so that they have a root tag and then surrounded by nested tags. So that's all it really comes down to. And then you have to specify the tags in the right way. So tags are something like, okay, they match. And then you can also have an empty tag that just basically says foo and then / and then the angle bracket. But so I'm sure that all of you have seen this kind of stuff, like in HTML and other places. Yeah, so the tags are case sensitive. That's something to keep in mind. But basically, we have something like this right here. This is a standalone. This is well-formed XML. So basically, you say, okay, this is what the actual file looks like. You say the version is 1.0, sure. Standalone is yes. So there's no DTD. There's no nothing kind of regulating how I nest these things. So I could just go in here and so I have bars and I have a bar, and then under bar I have a beer, and then ultimately this tag right here gets closed off there. So I have a list of beer and their prices, and there's nothing that says I can't go and start basically including other tags here, like maybe defining live performance or something like that, right? So I can just kind of put in whatever I want when I write the document, because there's nothing regulating it. There's no document type or schema essentially that's regulating it. Okay, but again, that's nice if you just kind of want to be very, very informal. But a lot of times you want to be a little bit structured, and then you want to include this DTD, this document type definition. So these document type definitions are not specified in XML themselves, as we'll see in a second. But what they do is they define basically it's the description of the tags, and then what can be the nested tags. This right here, you see PC data, that's parsed character data. Okay, so here's a document type definition, and what it starts out with here is it starts out with this. Okay, the document. This is going to be the document type of bars, and then it's got a set of specifications here. And then the first specification, these are all element specifications, so these are describing tags. So what this basically says, it says the bars tag can have And a star here means from 0 to infinity. So from 0 to as many as you want, bars within it. That makes sense. You have bars, and then inside that you have a set of bar tags. Now the bar tags here have the name, and then they have the beer, and this is between 1 and infinite number of beers that they serve. And then we have, going even further down, we have the idea of well, we have beer. We have the idea of a name here, which is just going to wind up being printable character data, and we have the idea of price. So let's take a look right here. Those are just going to be text, like straight. What this means here is it just means it's going to be straight text. There's going to be no contained. It's not going to contain any tags within it. It's just going to have raw text in there. So yeah. So the this is kind of standard cleany notation here, but what we have here is, let's see here, if we can include it all in one spot here. But here's an example of a DTD and then plus a set of data that conforms to the DTD. And as you can see, these all conform to the data. So this is kind of what this allows us to do then, is it allows us to talk in terms of validity. All right, so there's the first kind of hurdle, and that is just basically syntactic compliance with XML, and that's what you get with standalone. But then once you include a DTD, it's not standalone anymore, but you have like a DTD, then you can talk about validity. So in this case here, if I put like, I have bars and I have a set of beers here, and then actually under bars here, I try to see there's bars, we have bar there, and that closes off right there, and then we have beers. If I try to put a beer at the top level here, right under bars, that will be invalid. Okay, so when you check the validity of the document right here, compared to like this DTD, if I had right here where the mouse is, if I had a beer there, that would be a violation, because bars is only supposed to contain bar as the immediate sub elements. All right, so that should be hopefully be fairly straightforward. Now, okay, let's see if we can, all right, so I think that's all pretty straightforward here. But typically what you'll get here is you'll get the document type won't be, the actual data file will only make a reference to the document type. And typically this will be a URI. So this will basically point off to some standard definition of the DTD that's sitting somewhere on the internet, so everybody can comply to it. Okay, I guess I have some questions here. Yeah, XLS. Yeah, so that other stuff that we're not going to cover that stuff. The XLS I can't remember what XLS exactly stands for. That stuff is not being used so much anymore. But let's see, like there's like the style sheet stuff, but do you use a DTD instead of a schema? Yeah, well, there's something that's called XML schema, but we're not going to cover that. But basically, we can just think in terms of the DTD being kind of like a schema, like a relational schema. XLMS. Yeah, yeah, I see. So yeah, the XML style sheets, I believe, is what we were looking at there. But this was just a private question. But the point here is that it's kind of like a schema, but it's not like a full schema where you're putting in the types, and you're certainly not putting in stuff like primary keys and that kind of stuff. So it's not as it's not as strong as a relational database schema, but it's kind of serving a similar purpose to structure the data and to put at least some kind of regulations over what can be a legal document. Okay, so what we have here then is we have this will be a URI typically, so it'll point as like, so maybe if I'm like the head of the Meat and Poultry Association and I want all the participants in that industry to use kind of to have so they can send documents to one another, I would then publish on the website the DTD, and then all the people who are using whatever tools they wanted to construct the documents could then check for validity of their documents before they get transferred to other parties. All right, so that's kind of the practical argument for these kind of things. So, but the reason why it's called semi-structured as opposed to structured is because it's not providing the full kind of structure that a relational database does, but it's a lot easier for people to work with. All right, so that's kind of the idea behind it. Now, attributes are, so if you notice, so you know, if you look at something like HTML, which is very close to XML, but strictly speaking, it's XHTML, which is fully compliant. But let's not get into that. That's just a kind of a quirk of how things got worked out. But if you just kind of think of terms of HTML, we have the idea of attributes. So we have the idea of, you know, you have like the actual data, like Joe's bar here. But then what about like putting, like we could have the name of the bar here. We could actually sneak that in as an attribute over the bar. So a lot of times it's called like data or metadata. That's kind of how they tend to refer to it in XML. So that the metadata is what's coming in as attributes. That's at least kind of you know, the initial, I mean, how that happens is kind of, it's arbitrary. And, you know, what you can put in a tag, you could also put it as an attribute sometimes. And it's kind of a matter of taste and design as to how you do that. So there's no really hard and fast rules about that. But what we do have is we do have the idea of having attributes inside the tags. And the way you do that in the DTD is you define, instead of defining just elements, right? Instead of defining just elements, you also have at-lists, which are attributes, okay? So let's just look at an example of that. So we might have this right here. We might have like under bar. So under the bar tag, we would like to have an attribute called kind, which is going to be character data. And implied basically means that it's going to be optional, all right, as opposed to required. So you don't have to specify it, but you certainly can. So here's an idea of, here's where that would be then specified. So bar kind is a sushi bar, all right? So that's how that's coming in. So we're almost done now with XML. Now notice here already, for those people who are familiar with JSON, you know, JavaScript object notation, XML is already getting a little bit more expressive. So JSON's kind of ultimately wind up being a simplification of XML. But they're very similar. They're very similar. Well, there's some slight differences, but we'll stick with XML for the time being here. But I guess the point I'm saying is that JSON doesn't make this distinction between the attribute and the you know, just basic value. All right, like the tag set. So it's a little different that way. All right, so that we have an attribute. Now another thing we have, and this is kind of part of the, you know, this is, we have the notion of an ID or an ID refs. So we have a single ID and a set of IDs. So IDs are supposed to be unique for each tag. So each tag, if you give it an ID, it has to be unique for it to be valid. All right, so that's just exactly how, I mean, you get warnings if you do that otherwise. I mean, when you look at, I mean, if you generate, or if you're automatically generating HTML, for instance, and you have two elements that have the same ID, then a lot of times it will at least complain and give you a warning. So what we have here then is it's basically, we have the type of the attribute is ID. So whereas we had the type up here as a C data, we can also have a type of ID. So we come down here. Let's see. So here's a kind of a bigger example here. So we have the on bar, we have a name, and that's an ID. Okay, so you can't have two bars with the same name, and it's required also. So you have to specify a name for the bar. Then what we have here is we have an ID ref type. So ID ref type actually winds up being a set. So this is definitely, not only do we have this tree structure data, but we also have these idea of these sets of IDs. So we're definitely way beyond first normal form now, right? We've gone into allowing for, non-atomic valued attributes, as it were. Okay, so again, let's see here. We have the ID, which is required, and then the ID ref, which is required. So these are the, as we'll see here in this example, let's see, do we have another ones here? Sold by, we have a beer, and then, okay, so we have basically the, let's see, we'll get to right here. So bar is Joe's bar. So that's an ID, right? Because it was declared as an ID. Name was declared as an ID, right? So there cannot be another Joe's bar in the document. Otherwise, it won't be valid, right? So we have that Joe's Bar sells the beer Bud, and then we look right here, and Bud right there. This is also an ID, right? Because the name of the beer is also an ID, and this sells is actually taking an ID ref. So let's see if we get an example of that. Wait. I think we're going to see it in the next slides I give, but let's see here. I was going to look around for this. Maybe I can make an edit here. Oh, here we are. Here's an example. So we have first of all, we have the bars here. We have all the bars, and then now we actually have beer here. So if we look at bars, so before I was talking about you can have like basically the way this is structured here is you're going to specify the set of bars. All right, these are all the bars in your database. Then you're going to have all the beers in your database, right? And then the beers. So we have, here's the first bar is Joe's Bar, and then we have all the other bars. Then we have the first beer, and then we have all the other beers. But look at this beer here. We have the name of the beer, which is an ID type, so there cannot be any other Bud. And then we had sold by, and then notice here we have this. We have when you specify these things, it's not like Python where you have double quote and single quote are the same thing. Then they're not in XML. So what you have here is you have a double quote that always starts out the actual literal value for an attribute, and then you have Joe's Bar, and then notice you have space here, and then you have Sue's Bar, and then ... going on, right? Okay, so when people think about this, it's like, well, all right. So we have a set right here. These are all the bars. These are going to be all the bars that are sold by, these are all the bars that are selling Bud, okay? And then if you go into the bars themselves, then you can actually find Bud and see how much it costs, right? So I want to stick here. I want us to kind of think about this for a second here because this will kind of come up, be useful. All right, so this is kind of a strange syntax right here where we have the ID and then a space and then the ID. So what does this tell us about what needs to be true about IDs? I mean, this tells us that we cannot, this is kind of like an ID as an identifier, right? So in other words, in a programming language, you cannot have a variable named the space big space red, right? You have to run them all together as the big red, right? As one. You can't have any blank spaces inside of a variable name. And likewise, you can't have any blank spaces inside of the ID inside of XML, right? Because otherwise, this would then become ambiguous or strange, right? Because the way these are getting separated are with spaces, right? So that puts a little condition right there. So if we look back at this, there's a condition on an ID. An ID can't have blank spaces in it, okay? So that's something just to kind of note. Another thing to note here is that given this data we have here, could I get, all right, so if I wanted to get, well, we have the bars selling the beers, right? So the thing is that there's, there's a couple things to say about this. So one thing to say about this is that right off the bat, okay, let's consider a query we might want to ask, and that would be like a query of saying, all right, could you give me all the bars that sell Bud, Prips, or Falcon? Okay. Now you have there's two different ways of solving that query. One way to do that would be to go into the bars here, and then just simply search out the the presence of Prips, Falcon, or Bud. Another one would be then to go down here to the beers and then resolve it by actually just grabbing out the IDs of the bars for those three beers, right? And then doing some kind of intersection of them all, right? So if we're thinking about how we're going to actually do queries over this, we have the power to actually kind of do just general queries over this, but this kind of shows a little bit of an issue. That is that what says, can there be inconsistencies here? Is the DTD structuring able to tell us that, listen, if we're doing a reference here saying that a beer is sold by Joe's Bar, can we make sure that actually it's true that if we go to Joe's Bar, that bud is being sold. It is in this case, but what if we have another, what if Sue's bar comes later and then Sue's bar doesn't actually have a record of selling bud? All right. So what it shows that you can have these inconsistencies in the, you know, it's a little bit, it's already a price we're paying to go to semi-structured. All right. So I hope that makes sense. Is there anything else to say about this? Okay. Well, anyways, you can, I mean, there's also redundancy here too. We have this redundancy problem because, well, that's what would be the cause of the inconsistency. One might actually argue that you just want to get rid of this down here, the beer, and keep everything in here. And then if you wanted to figure out the bars that sell a certain beer, just derive that from the data itself. So you don't allow for these inconsistencies to crop up. All right. Empty elements. Yeah. So we've seen this in HTML, of course. But the idea behind an empty element here is you can put everything in attributes and then just have no containing tags. All right. Yeah. So okay. So that's your basic XML. So I think that probably you guys have seen that before. Maybe you learned something new. I gotta get rid of that. Now let's see. So am I still sharing that screen? I think I am. Okay, let me just get a screen show here. Present a slideshow. All right, so I take it you guys can hear me? Yes? Or I'm not hear me, but you can see this thing. Query languages for XML. Can you guys see that?
Yes.
Yes. Okay, very good. All right, so so we have, and you know, if there's any questions, just put them in the chat here. In fact, but I lost my chat now. Okay, chat. That kind of bugs. One second. I just need to. I guess I need to. Since I think I dismissed the. Oh, here we are. Maybe. No, I have the participants list, but I don't have the chat. So I'm sorry. I need to kind of undo this. And I'm going to get chat because there is actually a question in the chat. All right. And then I'm going to share screen. And share. All right. So, so what I mean, in databases, I mean, we tend to want to have some kind of query language. We've defined XML as like a data standard now, and we would like to have, you know, we have DTs over it, so we have some notion of kind of doing some integrity at least over it. And now what we want to do is we want to actually have a systematic way we can actually query it rather than just having, I mean, another option is you just write a program that just kind of, you know, parses it in and then starts, you know, you start kind of just taking however you decide you want to parse it, and then you just build everything from your you know, yourself, and you just have a program that goes and actually obtains the data you want. And actually, a lot of people do that with XML. I think probably a lot of you have had experience with doing something like where in Python there's like built-in XML parsers, and they give you like a tree structure that you can then kind of navigate yourself. And, you know, just in your program, you can just do for loops and navigate down and get into things. That's useful. That's quite useful. And sometimes, you know, you kind of need it. But from the point of view of just trying to kind of not have to have so much code hanging around, because then you got to maintain the code, it's kind of nicer to have these kind of query languages and make them kind of declarative in the sense that you can look at them and see what they're after. You can look at the query and you can kind of read and say, oh yeah, that's what that's looking for, right? As opposed to a big chunk of Python code that's parsing in the XML document and then going and fishing out what you need and et cetera. All right, so we want to kind of have at least some kind of querying, but with the understanding that in many practical cases, we're just actually going to we're going to have a full programming language over the actual data itself. All right, but anyways, the two components of this, you know, traditionally, is we have the XPath, and we have XPath and we have XQuery. Has anybody used XPath before? Anybody? I'm assuming nobody's used XQuery. I mean, although XQuery's got, I mean, in one of my own projects, I've used XQuery. I mean, so I'm using it in kind of yeah. I mean, I'm putting it into production. It's over logs, so it does querying of logs, and it stands up pretty well. So you guys are going to get experience with this in the third lab in using BaseX. So that's it's a pretty good XQuery engine. So you'll get experience with this, but by the end of the course, everybody will be able to say they've used XPath and XQuery. So basically, so the way it works is this: is that XQuery includes XPath. XPath is something that's very is much smaller, much simpler. It's just kind of this path language that's used inside of XQuery. XQuery is more of a full query language like SQL. All right, XPath. The analogy I can come up with is basically like when you talk about like simple little function languages in first order logic. That's kind of like XPath, and then the full first order logic is like XQuery. That's kind of the analogy to something kind of more mathematical. But let's look at XPath for a second here. So the way XPath works. Well, first of all, we want to look at kind of like what is the data model. So what's the underlying data model of XML? And basically, it winds up being kind of modeling. So like corresponding to the kind of fundamental notion of relation in relational databases. In XML, we're talking about a sequence of items. All right. So a sequence of items is either a primitive value, like an actual string or integer, a number value or a string value. Or a node. And then we have document nodes, which stand for the whole document. We have element nodes, which of course stand for, open and close tags inside the document. And then we have attribute nodes, which are those attribute values that are inside of a tag. Okay, so those are the nodes. So basically we have 4 different types of things. We have a primitive value, a document node, an element node, or an attribute node. And then just think of a sequence of those coming back, right? So that's the fundamental object over which querying is happening. Just like in the relational example, the fundamental object is always a relation. Remember how I always say, well, what's the, you apply a relational algebra operation on top of a relation. What do you get out? You get out a relation. Likewise, when you apply a XPath or XQuery operation to basically to a sequence of items, you get out a sequence of items. Okay, so it stays closed under a sequence of items. Okay, so that's kind of the direct analogy. Of course, these are a little more complicated. We have, it's not as uniform as just having relations, but it's kind of behaving to a certain extent, at least behaving. All right, so the document nodes. We'll start out with what a document node is. That's basically just it's just essentially just a doc around a URL, or in this case, this is on the file system here, but this could be an HTTP, this could be a URI, right? So this could be referring to something all across the web. All right, so that would be a document node, okay? So here's the DTD of our running example. We have the bars, we have bar as an element with a bunch of prices as sub-elements, and we have a bars. This is the full set of bars in the city, and we have we're going to have the set of bars followed by the set of beers. We've already kind of covered this, and then we have the IDs here. These attributes of type ID. The name of the bar and the name of the beer are the IDs, and then we have the sold by, which is a set of bars that sell that beer. Okay. So right here, this is an element node, right? So it's, there's the bar. There's an attribute node. The whole thing was the document node, right? There it is. And of course, we have the literal values here, which are going to be like the 3.00, which are also an item. All right. So what we get here then is essentially what we're getting a graph, or it's kind of a graph. It's like a tree, but it's got these kind of back pointers in it because of the IDs. So it's not just a tree. It's got a little bit more to it, so that it has these back pointers. So that's kind of the data model. So this is the document item, and then we have the element items, and then we have the attribute items. Is that gold? And then we have the primitive values. Okay, so this is kind of what it looks like here. So it's like this is potentially one. This is, I guess, the Joe's bar. I guess Sue's bar is in there somewhere as well, or would be. But we have the bar, yeah, we're pointing off to Bud here. And then we have the sold by, which is a, sold by is an it's an attribute. And then it's got a list in there above all the, and these are all back pointers that are going to point back to the bar. All right, so now we talk about paths in XML documents. So this is like an XML document represented as elements, or as a tree of elements. Right. So the path in XML document so XPath is a way to describe these paths in this kind of a document. Okay. So the result described in the path is a sequence of items. Okay. So like I said, everything stays closed under a sequence of items. So any XPath operation is going to be over a sequence of items, and it's going to then return a sequence of items. So the simple path expressions are sequences with slashes and tags. The easiest way. So they start with a slash. So this forward slash here at the top, this is just like directories inside of in Linux or Unix, right? Same basic way, at least when we just talk about the forward slash operation. So basically forward slash bars, forward slash bar, forward slash price. What that will do, that will go down to the bars here, then down to price here, and then it will list all these prices in order. So it will get all the prices at all the different bars. Okay, so all the reachable ones. So it's just like doing. I mean, I'm sure a lot of you guys have done something like in Unix. You'd say like ls. Well, you could say ls forward slash star forward slash star forward slash star dot XML, and that will give you all the XML documents that are 3 levels deep by many different possible paths. All right, so the same thing's going on in XPath. All right, so so hopefully that's pretty clear. I mean, you'll get some practice with this in the third lab. All right, so assume the first path, when the forward slash always represents the root, and then we basically wind up with, so this is forward slash bars will give us the sequence of items, which are just going to be bars, right? So in this case, we'll get this bar, and then we'll get the next bar and the next bar, right? So we'll just get all those. We're getting back a sequence of element tags, or elements rather, sequence of elements, which are all the bars inside the file. Okay, that's what slash bars gives us. And then slash bar, that will give us all the elements that are under a bar. So that will actually give us all the prices, because I think only prices are under a bar. Okay, so that would give us the prices. The price, what this will actually give us out then is it goes down and then actually will grab out the literal value. Okay, so the literal value will be plucked in that last in this last example. So it goes down bars. Okay, now we have a sequence of bar. Okay, then we go down into the bar. Fine. So we have a sequence of all these prices for all the different across all the different bars, and then it's going to go even deeper into that, and it's going to then pluck out the value for each of the prices. All right, it's not a very useful query, but that's what XPath would give us. Right. So that would be basically, this would return us a sequence of items, and the items are all primitive values. That's what this would give us. All right. Now, I'm just going to kind of go a little bit over here, maybe, because I just want to finish up XPath before we get to XQuery. So we can take our break, but let's get XPath done after that. But you can have what are called attributes inside the path. So, well, you can use the attributes as well inside the paths. Because notice what these things are doing right here is they're just going down the elements. So we want to also go off in the direction of the actual attributes, like the beer here or something. So the way you do this inside of XPath is you put an @ symbol out in front. So basically, if you say this right here, if I say the bars down to bar and then down into price, but instead of grabbing actually the value out, what we want is we want to grab out the attribute, the beer. So what this will do is this will return to us all the attribute nodes as a sequence of that. The result will be the sequence of attribute nodes. That's what will then be pulled out. So this at symbol right here, it goes off onto the attribute if it exists. Okay, these are required attributes, so it'll always exist. But if it doesn't, it'll skip it. All right, item sequences. So until now, all item sequences have been sequences of element nodes. When a path expression ends in a attribute, the result is a sequence of attribute nodes. Yes. Okay. Paths that begin anywhere. So you have the idea here then is that if you have / it's just part of the syntax. That just means match anywhere inside the hierarchy. So, one sec. / price means that anywhere, no matter how deeply it's nested in, we're going to grab out price elements. That's what that / means. All right. Wildcards mean any matching element. So these are all the price objects at the third level of nesting. Okay, so it doesn't matter how you reach them. This like you can do that like with ls. That's that Unix example. You can put stars in your LSs like that as well. All right, this is the bar element. These are the bars. Bars / bars is all the bar elements. So this will give us all this. You can put the star at the end also here, which will give us back all the elements that are under bars. So that will give us both the beers and the bars back. Okay, now finishing up on XPath here. There's not much to it actually. We're almost done with it. Now we can also have select conditions inside of XPath. So what you can say is something like this. You can say bars. So you go down to bars, down to bar, down to price, and then inside of price, so inside this value here for price, you can say dot, which basically is the current element, is less than 2.75. All right. So that will actually do a condition on the actual data value inside of a tag. All right. Not an attribute. This is the data value inside the tag. So it's smart about how it does kind of the smart coercions so that it can see that this is a number. Okay. So it does a little bit. It uses a little bit of intelligence to do that. You can confuse it if you go and you put in here, you put like a string value, it'll then basically not know the answer and it won't qualify. Okay. So if it's, it's like similar to kind of the true false unknown inside of in SQL, it has to be true for it to be passed back as an answer. So that is the way you can do conditions on the actual literal values at the leaves. But what about doing conditions on the attributes? Well, you do that by saying using the at symbol to refer to the attribute again. So this right here is basically going to say, give us the price elements where the beer is equal to Miller. So this will give us the prices of all the Millers across the whole data collection. Right? So that could be useful because then you can find out which bar is serving for the cheapest. Right? We're getting toward that kind of critical question. Yeah, critical query to answer. All right, so now there's this notion of axes, and the only axes that really makes some sense that I see, that you use a lot is this one. You have a shorthand for it. Basically, the axis is kind of what direction does XPath take when it gets to that node. So you can do attributes. So you instead of saying this right here with the add attribute, you could say basically say you want to use the attribute axis here, which you would never do. You just kind of use this syntax. And likewise, the most important one here is the parent, the dot, because a lot of times what we'll see here, maybe what I'll do here now is go to just maybe I can type it in the chat, or well, no, I have maybe a better idea. I can actually just type it in here. Or not. No, I can't. I'll type it in the chat so that everybody can see it, I hope. Everyone publicly. Okay. Test. Nope, that's going to a private thing. Everyone. and meeting. All right, so this is this basically this idea here. If I say bar, oops, forward slash, rather bars. Actually, I'll use a little more here. Bar forward slash bar. That'll give us any of the bars, and then what I'll do is I'll go down into price, and let's see here. I'll just basically do this one we had before here. So if I say bar forward slash price, and then I say I want the price to be less than 275. Okay, so right there, what that gives us right there is that's going to give us all the price elements where there's a beer where the price is less than $2.75. So now if I do this, however, good. Okay. All right, dot, and then all right, so everybody look at that XPath expression there. So I'll just voice it out here. It's forward slash bar. So that means it'll go to any bar, and then it'll go down into price. Okay, and then it will make sure that the price is less than 2.75. Now, there's only a certain number of prices that are less than that. So think of it this way: we've located a set of elements where that's true now. And then we have the parent operator. So we're going to pursue the parent axis. So we go dot, which brings us up again. And what that does, that brings us up again from the, let's see. Oh, actually, now we're up at the level of a bar. Okay. And then what I'm going to do is I'm going to pluck out the name of the bar. All right. So what does this XPath query give us? What is this actually giving us? Just linguistically, what is this answering for us? What question? I'll answer it, I guess, unless somebody else wants to. What this is giving us the bars that have at least one price of a beer that's less than 275, and we're getting the names of those bars. So what we've done, I term this a squirrel around. It's like a little squirrel. The little squirrel ran down. It got the conditions checked out, and then it hopped back up, another branch, and then it fetched the right data. So the actual following of the paths and the conditions actually is doing some kind of meaningful work for us. Okay, this is XPath. So this is not XQuery. This is XPath. So inside of XPath, with the squirrel around, I mean, you can't solve all questions with squirreling, but you can. There's a lot of questions you can solve with squirreling inside of XPath. Okay, so it's kind of a nice technique to have. So you'll see that you'll squirrel around a lot when you do just pure XPath. But this is just, I mean, but you can't do everything with it. So, but it's just to show that that's kind of what it's doing for us. So it's kind of a nice little kind of clever way in which the queries are getting we're using the way with the query is getting evaluated. We're getting some kind of logic in it so that it kind of solves something for us. In this case, giving us the names. Now, there'll be a lot of bars that sell a lot of beers so there's a lot of bars that will sell a lot of beers that are under that price, and those bars will get repeated. The number of times the name gets generated by this will repeat by the number of beers that they had under that price. Okay, so it'll find all reachable. It'll go through all reachable, the full reachability when it does the calculation. Making it so that we get distinct answers back. Then we're looking at XPath or XQuery at that point, because XQuery we can make it so that they're all distinct. It's just like an SQL. But I just thought I would show you guys that little technique. All right, so now let's see here. Let's get back at let's get back at, I guess let's take a 15-minute break here. So let's get back at 25 after, and then we'll just kind of finish up with XQuery. So back at 25 after, and I'll stop recording. I guess I have to stop sharing to stop recording, or to pause recording. So let's pause. Okay. Okay, now. So we finished with XPath. I'm assuming everyone can hear me. We finished with XPath, and XPath is, I mean, it's not really like a full query language, but it gives us something. Just as an aside, this GraphQL is kind of, it's not quite like that, but it's kind of similar. You're not given a really full kind of querying capability in GraphQL, and you're not really given full querying capability in XPath either. When I say full querying capability, I mean something like SQL. So I'm talking about like joins, like being able to do joins, and kind of having a lot more power in terms of how you actually present stuff and yeah, doing stuff like ordering by and doing formatting and this kind of stuff. So XQuery is it has XPath within it, and I'm assuming that it won't be long until JSON has something similar to XQuery that's going to be built up as well. So if you learn XQuery, you probably will be able to transfer some of that knowledge over into whatever comes for JSON. They might even have some stuff that might be competing. So even XQuery itself, there was a lot of different competing standards, and XQuery was the one that won out, and then the W3C went with that as the standard. So the same thing will happen in GraphQL. So it's probably already happening, but something will eventually win. Also, I should just make a point that JSON has JSON schema now as well. So there's the notion of adding some kind of DTD type capability to JSON. So it's, in a sense, the whole history of XML, XPath, XQuery is kind of recapitulating itself over JSON. So just keep that in mind. So let's just get back to XQuery here. I mean, XQuery does get used here and there. Again, like you'll be using it for your final assignment. But this BaseX is a pretty good engine that does it. So yeah, so you get some experience with this. So XPath is an expression language like SQL or like relational algebra, where any XQuery expression can be an argument of any other. So basically, it's this idea. You saw it in SQL also, where you have kind of like when you say select from, you can have a whole SQL query in the from clause instead of having a table named. Similar with XQuery, you can have XQuery expressions within XQuery expressions, and then the semantics is that they get evaluated at the leaves, and then the values propagate up, or the not the values, but rather the sequence of items. So it's the same data model as XPath. So the sequence of items get propagated up. All right. So if it happens though that when you're doing XQuery, because it can get a little bit complicated, and you wind up generating empty sequences, so you get this kind of, or you generate like a sequence of like a single element, an empty sequence, and then a pair of elements, it will actually flatten these out to keep things kind of coherent. So it will actually do flattening when it does its evaluation. All right, that's something to keep in mind. So that'll come up. So it gets a little bit complicated in XQuery, but let's give it a shot here. All right, so XQuery is built on what are called flower expressions. So what flower means is that you have a for and let clauses. So F is for a for clause, and L is for a let clause. And then W is like where, like an SQL where clause, where the conditions are being evaluated. And then an R for return. Okay, so this is the return clause. This is where you actually build up the return expressions. All right, so let's look. Semantics of a flower expressions. So the for loop, this is actually how we get joins to work, and we'll have an example here of a join. You can't do joins in XPath, but you can do them when you go up to XQuery. So the for it'll find all the bindings of a variable, all the plausible bindings of a variable. And a let will just give us a local definition. So we'll see examples of this. The where clause, if it returns true, then it returns the invoke clause, where the answer is appended to what's being prepared for the return. So let's take a look. All right, so for clauses. maybe it's best just to kind of go to an example here. Hopefully get one here. Okay, so let's look at this right here. This expression at the top here. This right here. Let's see if I can, where my mouse pointer is now. I can't, unfortunately. Can't highlight stuff. So where this $4 $beer. So $beer, that stands for a variable, all right, in document. And then notice here we have the document. There's a document node, right? The bars example, and then /bars/beer at name. So this is an XPath expression here, right? Where we start out with the document, and then we go down into the bars, and then down into the beer, and then we pluck out the attribute of the name of the beer, right? So this is getting us the names of all the beers, right? So it's going to go through here. And it's going to find. So if we have, and another thing also to keep in mind here, this is most likely going to be something. This is what's kind of nice about XQuery and this whole kind of stack. Is this is going to be a URI. So this is maybe going to point off to some document that's in a different country, right? So it's kind of very webby. It's very, very easy to kind of to integrate stuff across the web. So when you evaluate this, you can just go off and you can pluck this XML file from God knows where. All right, and then you go down, you get the names of the beers, and then so what here? Let's look at the semantics here. What's really happening? So it's the beer is getting bound for everything so this right here, this is an XPath expression, and this is going to return then a sequence of items, right? And for each of those, in this case, it's going to be an attribute node. For each attribute node in that sequence of items, we're going to bind in the variable beer, right? So it's going to range over all of those. Each time, now there is no where clause here, so it's just implicitly true, all right? So for each time, what we're going to do then is we're going to basically append onto the return, we're going to have beer name, and then we're going to have the brackets here, and then the variable beer. So what the brackets do here is they force the evaluation. Otherwise, it's ambiguous. So what this basically, I mean, if you didn't have the brackets here, what it would do is for every beer, it would print the literal $beer, right? But you need to actually make it so that the $beer gets evaluated. It's not a literal $beer, rather it's a variable reference that's getting evaluated. And the brackets here are what forces that. Okay, so that's something that a lot of times you'll test this and outcomes like, oh yeah, there's 100 beers, but then I get just beer name and then $beer and then beer name, but that's not what I want. I want the actual beer names. Oh, I forgot. And then you go in and you put in the brackets to force the evaluation of the variable, right? Okay. Yeah, so then the result is something like this: is Bud Miller, et cetera, et cetera. Okay, so that's an idea of a for loop, right? So the variables are binding in. All right, now the braces, that was what I was talking about a second ago, is that the braces are what's going to force the evaluation of the variable. All right. Now sometimes it gets a little smart about it. So if you're just returning $, so if in this case, if you're just going to wind up not having brackets here, not having a tag name here, but you're just going to take away all that, and all you're going to return is $beer, then it gets smart about it because it says, wow, the only way that can make any sense is that it's a variable reference, and then it will do the evaluation. I have mixed feelings about this kind of stuff. I think a lot of times it's better to keep your languages terse, but the more you bring common sense in, the more the more, well, there's, I mean, people have heard of like duck semantics. This is kind of what this is. XQuery uses what's called duck semantics, like quack, quack, a duck, right? Duck semantics. And that's basically, if it quacks like a duck, and if it looks like a duck and it quacks like a duck, it must be a duck. All right. So duck semantics is what's being applied here, where the language itself gets kind of smart about doing some type inference and then doing stuff for you. I'm a little anti-duck. Okay. I mean, maybe call me old fashioned, but I like to have it so that keep things very terse, and it makes the implementation easier as well. Implementation of the language, that is. Okay. So this is kind of a duck semantics here. All right. Let clauses. Okay. So lets are they just are kind of giving you a definition of a variable. It's like, like a let in a programming language, where it's going to get just one assignment. One assignment is going to happen to the variable every time you run the query. So, so it doesn't cause iteration here. All right. So this right here is like, let the document equal that. Fine. So now you can have like the $D. You can then, have, it helps you out because you can then use that later on. Maybe there can be multiple places you use it later on. But right here it says let the beers now. So look at what's happening here. That's going to be the document. Fine. Let the beers be, and then it's going to just do this. This is going to get the beers variable is going to get assigned a sequence of items, but it's not going to iterate over them. It's just going to grab them kind of in one foul swoop. So there it is, right? So these are going to be all the names of the beers. And then what's going to happen then is it's just going to basically, since we're going to do the return here in the beer names, it's going to do an expansion here, and it's going to have every single one brought in because they got assigned as one in one foul swoop, as opposed to when we had this as a for loop, right? Okay, so I hope it makes sense. Order by. Order by actually should happen before the return. So order by is going to give us an expression that we can, it's kind of like similar to the SQL ordering by. So it's here's an example here. We're going to order by the price in this case. So now when it does this, it's going to do this by just the actual literal value in this case here. Order by the bindings of the values inside of, all right, so it's going to automatic conversion. So it's doing a lot of kind of automatic conversion, which can lead to trouble, but can also make things so that it does the right thing. All right. So there's our order by. Okay, so let's see here. A lot of this you kind of just play around with base X and you kind of get things to work and you get a kind of hang of it. All right, so comparisons. There's a little bit now it gets a little bit tricky in terms of the semantics of comparison. Let's see. What we're going to do in comparison, we'll show the comparisons here in the context of our biggest XQuery query in this lecture here, which is going to show a join. So here's what we want. We want to create what we're after. We want to have, let us produce the price elements from all the bars, okay, for all the beers that are sold by Joe's Bar. So let's think about this for a second. We have all the beers that are sold by Joe's Bar, all right? Let's say there are 10 of them, all right? These are the 10 separate beers. And what we want is we want to have the price elements from all the other bars for exactly those beers. So they have to be the beers from Joe's Bar. And we're going to, it's maybe a comparison between what are Joe's prices like compared to other places. So the output will be this BBP elements with the names of the bar and the beer as attributes. We keep those as attributes, and the price element as a sub element. Okay, so what we're going to have here is these BBP. So let's say that we have these 10 beers that Joe's is serving, and we have like 7 other bars. What we want is we want to have, for each of those other bars where they're serving a beer from Joe's, we want to have this BBP element, which has the name of the bar. So it's the other bar, not Joe's. And then the beer, let's say Bud. And then we want to pluck out the price element from that bar. All right. So the strategy is to create a triple for loop, right? So we're going to have a triple for loop with the variables ranging over all the beer elements, all the bar elements, and all the price elements within those bar elements. Okay. So then we're going to check to see that the beer is sold at Joe's Bar, right? And that the beer, and that the name of the beer and the beer that is being sold at Joe's Bar have an exact match. And then we're going to output the price element, okay? And then we're going to construct an output element. So let's just look at kind of how this thing is structured here. So this is our example of a join. And then we'll see that we have comparisons in here. Okay, so let's get all the bars. Okay, so this right here, he's just going to give us all the bars. Okay, so boom, this returned us a list of elements that are all the bars. All right. Strictly speaking, we don't need this. We could actually just have this built into the inside here, but we're just going to have it so that we have a list of all the bars here. So these are all the bars. All right. Now for each beer okay, so now we take the bars here and then we go down and we get the beer elements from all the bars. All right. So this is going to give us all the beers. Now we're ranging over all the beers. And then for each bar, under bars, right? Because if you recall, there was the beers, we had the bars and we had the beers under the bar in the bars table here. What we're going to do is we're going to be ranging over that as well, and then we're going to go over all the price elements for that particular bar and price. Okay, now where the beer, so now we have the beer. Remember the sold at. The sold at had all the IDs of the bars that the beer is being sold at. All right. Now that's a set. Okay. So this is one of these things that's a little bit junky about XQuery. Basically, when you have the equality between a singleton or a single value and a set, it will return true if this is in that set. All right. So this is really, I think, bad. I don't like this aspect of XQuery, that it does this kind of inferencing. I think it's not good, in my opinion. But it is what it is. All right. So this okay. I mean, what else do you want to have some other operator? I mean, I'm not a language. I don't have control over designing XQuery language, but this is just the way it is. All right. So what this basically says, it says this will be true then if the beer that we're ranging over here is at Joe's bar. And then we also want to make sure that whatever price we're ranging over here, the beer in that price is actually the same beer, has the same name as the beer that we're ranging over. All right. So that's it's not very efficient if you think about it. But then again, you have no XQuery is going to just kind of do it by by rote. It's going to go through all the possible combinations. It is not. This is kind of not in SQL. We haven't covered it. We will cover it on a little bit next lecture. We have the notion of an index, so that it can actually do a lot more efficient checking. I mean, it doesn't have to literally go over all the different tuples in the when it's doing the join. It can go over some kind of a small slice of them that match on the values. So that's a little bit of a problem with XQuery. But again, a lot of times when you're not dealing with that much data, it doesn't make that much of a difference in terms of performance. So anyways, once this happens, all that happens, basically, it means that we find a beer that was sold by Joe's, and we're also under one particular bar, we're going to find a price element that actually happens to match that same beer's name. And then when that happens, we're going to squirt it out we're going to tag it on to the what we're returning here, which is going to be a BBP element. And then we're just going to give the attribute here that where the bar equals the bar's name, and then the beer equals the beer's name. I don't know why if you guys can see that very well, but it's a little bit shaded out here. But and then we're also going to put the price in as the sub element there. Right. So, this is you have some questions in lab 3 where you're going to be doing something like this. So this is how you do joins in XQuery. All right. So you're literally actually calculating the join. Right. Boy. But it's still this business right here of that way, the condition. This is true if Joe's bar appears anywhere in the sequence. That's kind of just the way it is in XQuery. It's kind of junky. So this equality there is doing that. Let's look a little bit more at some other types of comparisons here. So strict comparisons. So to require that the things being compared are sequences of only one element, we use equality. So basically this right here is kind of our more notion. So instead of using the equals has this kind of, it's doing this kind of inference, and it can kind of be more general than just doing a strict comparison. But if you use EQ instead, then you get a strict comparison. So in this case here, this would give us the beers that are only sold at Joe's bar. So that would be something different. Of course, that would make it so the whole query that we had here was kind of pointless. But that's how to get strict. So so a lot of times you'll see that you're going to find that you're going to use an equal sign, the traditional equal sign, and that's not going to really work for you. And then you're going to switch it to an EQ, and then it will work, or vice versa. Okay, so comparisons of elements and values. So when an element is compared to a primitive value, the element is treated as its value. That is, if the value is atomic. So for instance, you can basically say EQ here, the stricter version, where 250 is going to actually equal the actual price here. So that this is true if this winds up being 250. But it doesn't work on larger elements if they actually just kind of look like one another. So the EQ here, since it's more strict, is basically saying do things like, so for instance, if we get out we reach this price element. Okay, so the bars, names, Joe bar, Sue's bar, the price. So these happen to be equal. If let's say that Joe and Sue charge the same amount for Bud, and we're using the stricter version of this EQ. What that actually is saying that are the elements actually equal? So this is kind of a notion of what would you say? I mean, there's like, we all have kind of like dealt with this issue of like deep equality or shallow equality. Shallow equality has to do with I mean, deep equality is do they actually, shallow equality is are they pointing at the same thing? And deep equality is do they literally mean the same thing? So it's kind of similar to that. But with this, what happens here is, since in the representation of, think of it this way, when you parse these things, the XML, although you might have Bud being a price of Bud being, $3 at Sue's bar and being $3 at Joe's bar. I mean, they're saying the same thing, but they're actually distinct nodes in the XML representation. So the EQ will have it so they don't actually equal each other. Okay, so this will be a shallow notion of equality. So if you want to make it so that you force them to actually yield actual data value, you're going to have to enclose this in a function called data, which will actually cough up the actual data value, and then you can do a straight equals, with the actual classical equal sign on that to get to do actual kind of deep equality. All right, so these are these kind of quirks that come up that can be annoying, but they do make sense if you think about it. So, all right, so getting the data from the element. So this is that was that function I was talking about, putting like data around it. So if you do this right here, price. So suppose we want to modify the return for find the prices of beers at bars that sell the same that sell a beer Joe sells. So basically return, all right, price equals, all right, this is something where I'll actually pull out the actual price. This is data. All right, I mean, it's something that I think it's better just to kind of experiment with it. In some sense, I mean, I think maybe doing this as a workshop lecture might be a bit better in the sense that just to kind of show using XQuery. But anyways, so eliminating duplicates. Yeah, so there's a distinct values function that basically can eliminate duplicates. So yeah, so here's oh yeah, so this is actually kind of nice. So what it's showing here is that well, this right here, this is actually two XQuery queries. So this right here, the internal one here is an external query, is an XQuery. It's it's a flower query, but it doesn't have a for. So it's let the bars equal that, and then return the bars, return their prices. And all of this right up here is also a, this is a XQuery being contained within an XQuery. This XQuery here doesn't have any for, lets, or wheres, but it does have a return. So it just basically applies distinct values over the sequence being returned from this internal XQuery. All right. Okay. The effective Boolean value. So that basically this, again, this is it being smart about what's false. False is that if it evaluates to 0, the empty string, or the empty sequence. All right, those all become, the effective Boolean value becomes false for those. So if you're doing any kind of conditions, and we'll get to that in a second, then the effective Boolean value winds up, it is like a lot of programming languages do this, right? What is the effective Boolean value of an empty list in Python? It's false, right? So there's modern programming languages do effective Boolean values. So you don't have to, it's a little bit, it courses the type into a Boolean. All right, so so name equals Joe's bar, here, that has an effective Boolean of true or false, depending on whether or not the name attribute is Joe's bar, right? Okay, so yeah, so if it equals, that's just kind of an equals, it's kind of pretty obvious. Yeah, so this this effective Boolean value of this whole expression here just has to do with whether or not this exists, whether or not you can find it, right? So if there's one in in the whole set, then this will be an effective Boolean value of true. And then of course you just have the way you combine these, and or nots, yeah, I mean, so this is pretty straightforward. 3 equals. So, right, let's see. So the reason why this becomes something kind of interesting is that you have these branching expressions inside of XQuery. In fact, XQuery is, I believe, is Turing complete when you use recursion. So you can actually build all your programs in XQuery, so they can do arbitrary things. But you have this kind of conditional. So it'll kind of evaluate what will be evaluated would be based on whether the effective Boolean value of this expression. Okay, so that should be. And then you get, this is kind of nice in a way as opposed to SQL, I suppose, but you get every, and you get the existential quantifiers as part of the syntax of the language. All right, so yeah, so sum basically means it's true if there's at least one x that has, so sum x in E, so in this expression here, so getting returned from this expression satisfies another expression. So yeah, so sum will just be something, there has to be at least one binding here that actually evaluates to true effective Boolean value for that expression there. And then every means that all of them have to do that. So you get, you have not, some, and every, so you get kind of the full logical ingredients. So maybe here's an example. The bars that sell at least one beer for less than $2. Okay, so we're going to basically do a for here where we get the bars we're getting all the bars inside of the document, where some $P in, okay, so in $P in this is kind of an expression here that says it's going to range over all the prices. This is kind of a way you're kind of sneaking a for in here in some sense. Over all the prices inside of the, where there's going to be some price, being yielded from this expression here that satisfies, and then we have the actual condition here that is less than 2. Okay, and then it will return the name of the bar where that happens. So this is an example of using a sum, and this is kind of a similar. This is like the bars that sell no beer for more than 5, so it means that everyone has to be less than 5. So it's using the every instead of the sum. Finally, there's this. This comes up quite a bit. That is that we have this kind of intrinsic operator called the document order operator, where inside the actual document you can say something like, well, less than means it appears before the other element inside the document. So this is actually quite useful sometimes. Sometimes there's no other. This is I mean, it's kind of more physical than like SQL, because in SQL you're not supposed to do this kind of stuff. I mean, you really have no statement over how things were physically arranged. You don't want to have your queries based on that. But in XQuery you can do that. So right here it basically says, is it true that the bud is going to be earlier in the document than Miller? Right. All right, set operators. Yeah, so you have all the set operators that it's all analogous to SQL. Okay. Yeah, so that kind of was a whirlwind tour of XQuery. But I mean, if you go through what's in base X, you'll see there's a lot in there. So it became a fairly large language, but it's fairly powerful. I mean, I think one of the ideas behind XQuery that never really it never really took off
But one of the ideas behind it was going to be a way to do kind of scraping. If everybody would have gone over to XHTML, then this might have actually been the way for us to have gotten kind of intelligent scraping, much more intelligent scraping, more query-based scraping of websites. But the thing is that because people didn't really go all the way over to HTML, it never really took off, unfortunately. So instead, like if you do scraping, so when people do scraping of websites, which is of course very common, they use something, maybe people have heard of it, called Beautiful Soup. That's the Python. There's some analogous things for Java. I think actually they have a Java version of that as well. But if you're using Python, then Beautiful Soup is kind of that's kind of a common tool that you would use. So what that does, that basically goes through and you fetch HTML documents, and it essentially turns it into a tree. So since it's not XML, it has to be a little bit smart about parsing the HTML the right way. And that Beautiful Soup can actually not be so. You might have to fiddle with it and work with different parsers to get things to work based on the scrape. But what it then gives you is it gives you a tree that you can then, Beautiful Soup has its own kind of way you can navigate that tree and pluck out data. All right, but one of the ideas behind XQuery was always that it was going to be able to do that. That it in itself was going to be able to do the scraping. I think in some cases you can do that, but it just hasn't become a general tool for that. But that was kind of one of the intentions behind it. The other things also that we haven't covered that became a fairly large issue for XQuery was stuff like updates. So it's not really like SQL is you have like, not only do you have the querying, but you also have the fact that you can make changes to the database, right? So it's a little bit harder to kind of imagine how what that really means in something like XQuery. So not all databases are just read only. It's there's a lot of, you need to do updates as well. And by the way, that's also a problem that GraphQL is going to have to face as well. Is that it's not just querying, it's not just reads, it's also writes. So that became something that lots of effort was put into. Well, a lot of people, I think that BaseX has some extensions for that for updates, but it gets pretty hairy, it gets pretty complicated. And especially one of the things, and this is kind of a heads up for the next lecture, is that when you start doing stuff where you have multiple readers and multiple writers, then if you don't control somehow how the reading and writing is done, then things can get really bad. You can lose money. So that's the whole issue of transactions. So how do we actually allow for multiple readers and writers over a database? So this stuff is essentially kind of punted on and not even addressed by these semi-structured query languages like GraphQL and XQuery. And XPath for that matter. They don't really deal with updates. So what we're going to do next lecture is we're going to look at this transaction issue, because it ultimately becomes a very fundamental problem, very fundamental issue in databases. And we're going to look at some other kind of a potpourri of different other things just to kind of finish up the course in the next lecture. But the next lecture won't be until next Monday. Before that, we're going to have recitation on Thursday for the normalization recitation. So yeah, okay. So with that, I think let me know. Just put any questions in here, and I can try to answer them in the remaining minutes here. So does anybody have any questions about this or comments? Doesn't look like it. Oh, I'm waiting here. Okay. Yeah. All right. So your lab 3 should also, yeah, I'll be uploading old exams shortly. So yeah, exams are coming up, and the thing about the old exams is they weren't done under the, well, the one last year kind of was, but it was that was right at the beginning of the COVID. I'm going to have a little bit of different kind of philosophy about how I'm going to run the exam, because I can't, we have to do everything online. So it can't be something where, normally I would have a closed book exam. I would have it so you guys have to do stuff from memory, but I can't do that anymore. So I have to kind of make it a little different. return before it. That was a question about the distinct value return before it. Some examples online don't have it. Yeah, it does need to have return. I mean, the thing is, so if you're working, yeah, this was a private message, but somebody had an issue about you go out to different examples on the web for XQuery, and they don't. Really, the full arbiter of what's true or false is not me. It's not the web. It's you and like the particular engine you're using. In this case, BaseX, I imagine. So you really got to be kind of empirical about it. I mean, there was I'm not really sure what happened with the history of XQuery's implementations. I mean, this is one of the big problems, of course, is that, I mean, I think with GraphQL, things are still in pretty good shape because it's so simple. So it's a reference, they have a reference. It's a specification, right, of an engine, and then you have lots of different vendors who implement their own versions of it. XQuery had the same thing, but I'm afraid that XQuery it's more complicated. So you probably do have lots of like vendor idiosyncrasies, which is really unfortunate. This is why language design for query languages should always be just really, really clean and simple if possible. So my suspicion is that you have to have before a distinct value, you always need to have an explicit return. I'm assuming that's how the BaseX would work. And it's annoying when it doesn't. It's annoying when this is why I'm so anti-duck, because duck typing and duck strategies, or type coercions and this kind of stuff. I mean, it just makes it so that you get more really, really, really subtle differences between vendors, and that's always a problem. So, unless you stick with the same vendor, but that can be another problem. Yeah. So are there any other questions? Okay. Well, yeah. So I'll see you all in recitation then on Thursday. Okay.